This is a numerical technique, and I'm going to be using a computer to do that. That's why you don't see my pen out. Certainly, Wells uses a paper and pencil to this. His work was written well over 100 years ago, and I understand that. But we're going to move towards using a digital computer to do some of these problems over here. It's a tough read. We do recommend you read through it. And certainly as I read through this over here, again, I know it's a tough read. You read through it. You may not understand what you've read, but you still read through it. All right, so I'm going to tell you that the method that we're going to be doing over here, it's numerical. And, Wells goes through it. He does a lot of computation. He rounds things off. Reason that the computations are difficult. For example, over here, he's saying, 0.239 divided by 8.23 is exactly 0.02. I put a little footnote over there saying it's not true, but it's close enough. All right, close enough. But I understand why he's doing it, by the way. He's trying to make his computations streamlined and more consistent, all right, with getting a solution to the problem. But we don't need to do that with computers now. We can let the computer do the computation. We don't have to do it. But it goes through a lot of this business over here, and to me it looks like chicken scratch. But the bottom line, I guess if you were a student back then, you had paper and pencil. You would need that. You would need to get that chicken scratch down. But we're not going to do that. All right. So what I'm going to do is, I'll just kind of scroll through this. It's a tough read. I want to get to an example, and when I get to an example, what I'm going to do is, I'll talk about what happens over here, and I'm going to use some software to do it. And let me just reset. And I want to point out they're claiming that this equation over here. So I'm going to say x is a variable. And again, I'm kind of using a machine to check it out. And I'm going to say f is a function, and that function is a function of x, and it's x cubed. And I'll tell you why I'm doing this in a second. Minus 3 star x squared minus 2 star x plus 5. And what I want to show, if there's a root between 3 and 4 and it's a polynomial, I want to show that f of 4 is greater than 0. That's really easy for me to do. I don't have to do much arithmetic. That's 13. And I want to show you that f of 3 is less than 0. And that's minus 1. Now, what do I know? I know there's a root between 3 and 4 now. All right, so that's a given. So what does that? Let it be required to find the approximate value of the root between 3 and 4 of the equation. All right? Now, you might be surprised Sage could solve this problem. It's not an issue for it. And we could solve the problem. But we're trying to learn a numerical technique. So let's read through what it says. It says over here, let f of x. We've already done that. And the root is unequal between 3 and 4. First shift f of x 3 units to the left. How would you do that? You would evaluate f at x plus 3. Now, as I do that, I wanted to expand it. The reason for that, I want to see what it looks like when I do that. Someone's going to say, why are you moving it 3 units to the left? Now the root would be between 0 and 1, so the root would be a proper fraction. That's the only reason we're doing it. Let's see if we get what they say, which is x cubed plus 6x squared plus 7x minus 1. Now, this is where Wells and I might disagree about what to do, but what Wells does, he looks at this over here, and he says, well, if the root is a fraction, by the way, the root of this is a fraction, you can ignore the first two terms because they would shrink pretty quickly if it's a proper fraction, certainly more quickly than this over here. So what does he do? He solves, and write that down for you, and we can do this in our head, of course, for 0, and we solve for a, right? So, whoops, I made a mistake over here. Oh, you know what? I'm not solving for a, I'm solving for x. I'm sorry about that. We get to that later. That's 1/7. What's 1 divided by 7? Well, Wells says 0.2. It's really not 0.2, by the way. But I'm sorry, he says 0.1. It's not 0.1. It's 0.14, blah, 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 blah. But I understand why Wells says that. He says that right over here. It says it clear as day, all right, in his notes. All right, but it's not. It's not even that number. It goes on for some time, all right? So here's the deal. What he does, he starts to keep moving it. And this is where the chaos takes place. He keeps moving the thing, shifting it, so the root gets smaller and smaller and smaller and smaller, all right? So what I need to do is, I don't want to go through all that computation that Wells goes through. What I want to do is, I want to learn how to do this using a computer, all right? So I'm not going to do all the arithmetic that Wells does. What I want to do is I want to use a computer to do that. So Wells goes through a tremendous amount of arithmetic, including rounding things off inappropriately. But I realize why he's doing that. The arithmetic is difficult, but I don't need to do that with a computer. So what I want to do is I want to do this on a computer, all right? And I want to get to this. I'm going to clear the screen out, C-L-E-A-R, and I'm going to start typing in the code. As we do this, though, this has a lot to do with what Wells is doing. So I'm going to define two variables, x and a. That's a variable. X a variable, and a is a variable. Right? I'm just learning. I want to define the function, and this is the original function we have. And what was that function? It was x cubed minus 3 star x squared minus 2 star x plus 5. All right? Now, I want to go back in the notes. This is long, I know that. I want to look at the original function, which is x cubed minus 3x squared minus 2x plus 5. I did pretty good. Let me go back to my Sage. Am I going too fast here? No, I don't think so. So what do I want to do now? I want to do the expansion. Whoops, sorry about that. I touched my mouse there. I want to do f of 3 plus a, and I want to expand it. This is going to look familiar to you, by the way. What does this do? Remember, f of x has a root between 3 and 4. So if I do 3 plus a, it's shifting it between the root between 0 and 1. All right? So a will be between 0 and 1. All right, I got this over here. All right? So let me just scroll it. Make sure you know I got the same thing they have here. I'm just checking this out. I'm going to learn. And here's what Wells is saying. If it's a proper fraction, which we know it is, these first two terms can be ignored because they'll shrink very quickly if it's a proper fraction. Certainly quicker than 7a would shrink. All right? So what I'm going to do, I'm going to solve. We actually did this before, but we had an x in it. So I'm going to solve this here. I'm going to do a copy-paste. Equals 0. I'm going to solve for a. Now, if you want to approximate that, you just simply copy-paste, write the a, 1/7, and you put a decimal point in there. And so, you know, we did that before. I hope you remember that, all right? Now, what I'm going to say is the root appears to be 3 plus 1/7. Let me write that down. 3 plus. Now, why is that? The root of the function, right, the root of the function is going to be 3 plus that small number a, which is 1/7. I'm going to use a decimal. Just get a decimal point over there, all right? So I'm saying that's a root. All right, now let me just show you f of that number. Again, I'm going to do a copy. And my claim is this is going to be close to 0. And what do I get? 0.12. Now, granted, someone says that's really not a very good approximation, and I'm not saying it is, but it's a better approximation than just saying some number between 3 and 4. So I'm saying it's about 3.14. Now, what I want to do now is I want to repeat this process, right? And what I'm going to be doing is there's some number a that I need to add on to this. So someone says, what are you doing now? We're shifting this thing, still shifting it to the left. Let's write this down now. F of that number plus a. And we're going to expand. Now, what do I see? I'm seeing a cubic, right? Now, this a has actually gotten smaller. Now, what I mean by that is shifting it. It's still, you know, if I look at the roots, it's still between, you know, 3 and 4. Let me just do this over here. I'm going to take this here. I'm going to solve that. Let me just show you this is done in the notes too. Solve. I just did a copy paste there. Equal 0 for a. All right, I get that number there. So really, what am I going to be doing now? All right, I know it's tough to follow. All right, we got the a. What we're going to do is take this number up here that we found before. and I'm going to add that number onto it. All right? I'm going to add this number onto it. You know, crazy looking number, right? Let's see what happens. All right, I even got a better root now. I want to show you that. F of this number over here. And it even got better. Now, remember last time when I did that other thing, I was getting, you know, this number up here, 0.12. Now I'm getting something even better, even closer, getting even closer. All right, so what I want to do is I want to repeat this process. F of, let's write this down now. And again, I believe this is a shifting problem now, plus A, expand. All right. Let's do this now. Solve. I'm just repeating the same process over and over again. All right, hit return. All right, what am I going to do? Well, I'm hoping you remember the last root I got was that. Now what we're going to do is take this, and then we're going to take this, and that's a subtraction problem now. All right, we're adding it on actually. All right, I'm going to show now that f of this number here is even getting closer to 0. This numerical method. Now, notice that over there, it says e to the minus 7. What does that mean? That means 10 to the minus 7. This is an incredibly small number. All right, incredibly small. It's so close to 0, it's incredible. But I'm going to keep repeating this. All right, now, so what are you repeating? Let's remind you what we're repeating. We're doing f, and we're going to be doing a shifting. It's going to be this number over here, plus A. Expand. I'm going to take the last two terms. It's tough, we know that. Solve. Whoops, sorry about that. Those last two terms for 0. I'm solving for A. Get this over here. Remember this root over here. Let's write that down. Plus that number, which I'm just going to copy it because there's already a minus sign over there. Okay. Now I'm going to claim that f of that number is even a better approximation of the root. It is. Got minus 14 now. Right? That's 10 to the minus 14. It's really close to 0. I'm going to keep doing this. And someone's going to say, Wells kind of peters out after a while. We're not going to peter out because who's doing the problems? The computer is. Let's put this down now. Plus A, expand. You get the knack of this over time. Take the last two terms. I'm just copy pasting. I'm going to solve it. And again, we're solving the equation equals 0 for A. It's tough though, but the machine's doing the work. We get this over here. I'm going to take that root. This is my new guess, by the way. I'm going to add this number on. There's already a minus sign over there, so it makes it easy for me to just do copy paste now. We got a new approximation. Let me show you this one. All right, well, minus 14, that doesn't really change. So that's what I want to get across to you. At some point, the precision of your machine is not going to change. Let me point out what I mean by that. Look at our guess here after doing all that work and our guess over here. It's the same guess, all right? We found our root. So I want to point out, when I do this for the next problem, I want to make sure you know that I'm not going to be doing any hand arithmetic on it. So what I want to do is I want to see if I've learned how to do it. So I want to go over here. I'm going to clear. And I'm going to just type in the function now. Give me 1 second. F of x, I'm defining a new function, is equal to x cubed plus 4x squared. Whoops, sorry about that. I made a mistake already. Star 4x squared. Did I do okay? I made a mistake again. I'll type it out again. So minus 9x minus 5. Hit the return. No mistakes. When I get to I want to see if I get the right thing back. X cubed, 4x squared minus... Yeah, I did okay. So someone says, I don't remember what you just did. It happens, all right? So what I want to do is I want to scroll back over here. And I just want to communicate... You know what? I should probably read the question first. It says, let it be required, for example, to find the root between 0 and minus 1. So over here, I want to point out if the root's between 0 and minus 1, there's got to be a change sign over there. So I'm going to put it over here. I'm going to put f of 0 in. That's a negative number. And f of minus 1 in. And that better be a positive number, by the way. Notice my machine's doing the work. So yeah, I know there's a root between 0 and minus 5. But what do I have to do? I've got to shift this thing. All right, now with the roots between minus 1 and 0, so I got to shift it 1 unit to the right. So what I'm going to do over here, I'll write this down for you. F of, well, how do I do that? If I want to do 1 unit to right, it's going to be, I'm going to put a down, minus 1, expand. You see that? I just shifted it. Now someone says, you know, what are you going to do? And I want to point out, we kind of did this before. Do you remember? We did this, we did this. I did this over here, got this over here. And then what do? Well, let's go back. We had to solve, right? What were we solving? These last two guys. Let me put this down for you. I'll copy it. Let me post it over so it might be a little bit easier to see it. We're going to solve this thing for 0 and for a. I got that over there. I got a half. So someone's going to say, what are you going to do over here? Well, I'm going to write this down now. We're going to take this a and subtract 1 from it. Now, yeah, I don't need to do that, but I'm going to write down what we're doing. 1/2 minus 1. I can put a decimal, just get a decimal out of it, and we get this. Now, what I want to do is I want to do f of that number. Now, again, I'm just going to do a copy. I know it might seem crazy to you. I'm just going to copy it. Well, that's not really 0, but you know what? It's kind of close to 0. It's not great, though. So what am I going to do? I'm going to do another guess, right? So let me do this over here. F of, right, this is the tough part. Well, I'm thinking my root is this guy over here, right? Which is going to be, let's take a look at that now. So what are you going to get over here? We're going to put that root down. And then what do? That's my new root. And I'm going to, I guess, add a to that, right? And I'm going to expand. And I get this. I got a new equation. It's over here. Yep, I'm doing a copy-paste. Let me see if I can do that now. Solve that equation for 0, comma, a. All right, so I got that number over there. So what am I going to do? Well, what was my last root that I felt? I thought it was this one over here, right? I'm just going to copy-paste. And I'm going to add a onto it. And I'll put a decimal in just in case. I get this one over here. So I'm going to do f of that number. That's even better. All right, so I got another root now. When I say another good guess at a root. So I'm going to keep repeating this over and over again. So I'm going to do f. And I got this root over here. And there's going to be some correcting factor a, which is a proper fraction. Expand. And I get this linear problem in the end. I'm going to solve it. Yes, I know it's difficult, but the machine's doing all the hard work. I'm going to take that, whoops, sorry about that. I'm going to take the new root, which I found. That was this thing over here. And I'm going to add a to it. And what's a? It's this guy over here. No, I wouldn't want to do that arithmetic. So I'm going to say f of that new number is even better. Wow, that's really small. That's really close. -8. That's 10 to the -8. Well, you know what? I'm going to try again. I'm going to see if I get any changes. So I'll do this over here. F of, let's take a look. The root, right? What root did we find? I guess I found this thing, right? Yeah. Look at the key later. Plus a, expand. And you get this thing over here. Let's take this over here. That's that linear part of the problem. And we're going to solve it. First of all, I have to copy it. Let me get a copy first. I'm just using the computer to copy. So let's see, solve for 0. And we're solving for a. Wow, crazy looking number. So we got the root. Remember I found that root over here? Plus that a. I'm just doing a copy paste, all I'm doing. I won't have to type that again, right? All right. I want to take this new found root and see how good we did. -16. That's even getting smaller. Let's keep repeating. All right, that got better. There's no doubt about it. We're going to take this root, right? And we're going to type this in now. F of the root plus some small correcting factor to it. Expand. All right, we're going to take the last two terms. That's the linear part of it. And we're going to solve that for 0. It's going to be the correcting factor. I'm sorry, for 0. Hope I didn't type anything, but this will be self-correcting if I even make an error. Okay, so we got the old root. I want to point out what that is. Is this up here? And now we got this correcting factor. It turned out to be negative. All right. Now, I want to point out to you that there appears to be no change now. If you notice this, and notice the root we had before, there appears to be no change. So what I want to do is I want to go to the answer key, and I'm going to point this out to you, what we do in the answer key. We don't put a bunch of work down there for you, but what I do is I put the numbers down for you. So what I want to do is I want to go back over my work, if I can, and I want to start looking at where I start the problem. Now someone says, I don't even see where the problem starts. I think it starts up, let's see where it starts up. I think my first guess was this right over here. You notice the number there? What was my next guess? This one. That's right there. Let's go to the next guess. Was this one. I'm seeing it right there. What was my next guess? Was this one. I think when you're writing these things down next to one another, you start to realize we did pretty good in the beginning, but they did get better until there was no change. You notice over here, no change? That's when you're stopping. All right? Now, certainly, I'm using a calculator to do that, and I want to recommend that you do a calculator too. All right, let's look at this one over here. I'm getting better. I'm learning. and I'm going to clear. C-L-E-A-R. I'm going to type in the function. Let me pull this down so I can see it. I'm going to scroll this up. F of x is equal to x cubed. That's an assignment operator, by the way. Minus 2 star x squared plus 3 star x minus 1. They're saying there's a root between 0 and 1, so I want to show there's a sign change over there. So let's do f of 0. F of 0 is a negative number, and f of 1 better be a positive number. That means there's a root on that interval. Yep, I know that. All right, my understanding over here is that, how do we do that, right? So I'm going to say that I think what we do is we said there's a root there, right? So what are we going to do? Well, let's give it a try. Now again, let's say you can't remember. What do? You scroll back. Well, it's not going to be over there. We got to get that linear part. Do you remember? Well, here's the deal. I'm looking at the problem, and this is the linear part right over there. So I'm going to say my first guess, if this is fractional, would be just looking at its linear terms, which is 3x minus 1. Right? So what's my first guess going to be? It's going to be f of, well, that would be 1/3, right? And then I'm going to add a correcting factor on a. And we're going to expand this. Now, I'm going to put a decimal in there because I want a decimal number. Plus a, we're going to expand it. All right? So let me go back over here. I'm going to scroll down. We're on problem number 3. And I want to see if we're getting this first guess over here. So let's put this over here. I'm going to take this. I'm going to solve. We're trying to learn for a. I get this. Now remember what we did. My first guess is going to be the 1/3 plus the a. So I'll put this down. 1 divided by 3 plus 5/54. I'm going to put a decimal in there, and I'm hoping it's going to do the computation for me. What do we get? Let me see what I got here. 4. Did I make a mistake, sir? Let me take a look at it. Maybe I copied the wrong problem because I'm not getting the same thing. Let me see if I copied x cubed minus 2x squared, 3x minus 1, 1/3 would give me 1 minus 1, 1/3 plus a. We expanded it. Did I copy this right? I think so. Yeah, I think I did it right. Let's take a look. All right, let me go to the next one. I don't know why that number's over. I may have to correct it, but I'm not sure. Maybe I didn't start there. Let me do the next one then. What's going to be f of this new root plus a, and we're going to expand it. Let's hit return. I'm going to take the last two terms. I'm going to solve it for 0 and for a, okay? Let me take my old root, which is this thing over here, and I'm going to add on this crazy looking number over here. And it's crazy looking. Let me get this over here. Yeah, I'm starting to realize, we'll get the same number in the end, by the way. I'll tell you that. It's going to converge to that. So let's keep going. This is my new approximation. I'm going to have to change my notes, by the way. So it's going to be f of my new root plus a, expand. I'm going to take the last two terms. Whoops, I didn't mean to do that. We're going to solve for 0, a. We'll take our old root, our old good root, that's not bad, and we're going to add this on now. There's my new guess. I'm starting to think maybe my notes have, I have to correct the notes. So let's take a look at it. F of the new root. I want to show you that this is going to give you approximately 0. Yeah, it's getting pretty good. So the question is, are things changing? Yeah, they are. We got to keep going. All right, let's keep going. It's going to be f of that new root plus a, and we're going to expand. And we get this last two terms here. They're the linear part. And we're going to solve for 0. And let's see what happens. Let's take the old root, which is this thing over here, and we're gonna now do f of the old. I'm sorry, I have to do the arithmetic first. The old root plus this guy over here. Put a decimal there, make it do it. Now I'm going to do f of that number now. Even got better. It was minus 11 before, now it's minus 16. All right, that's 10 to the minus 16, by the way. Really close to 0. Let's do it again. That's the root we just found, plus a, some correcting factor. Expand. Let's do it. Let's take the last two terms. And it's going to be solve for 0 and a. Let's take our last root, which is this guy over here. And I'm going to add this thing on. It's a correcting factor. I know it's a minus sign, but I'm still adding it on. Put a decimal there. You get this over here. And what did I notice now? There's no change. But I want to see if they got that. They did. They got that answer. I don't know. Maybe I started with a different number. But here's the beauty of it. You could start with a different number, including an outrageous one. I shouldn't say outrageous, but not the same approximation. And still, it would converge in this over here. I just want to show you f of this final guy over here. There has been no change, by the way. All right, I want to point out by that. You're looking at these two things over here, no change. In other words, corrective factor was so small, the computer didn't even register it. I didn't copy. Let me copy right number. And again, I want to show you it's really close to 0. That's what we're looking for. Now, e to the minus 16 means 10 to the minus 16th. It's a really small number, all right? It's a pretty good root. Again, we're getting the same number over here, 0.430, 159, 709, 00, 1947. I must have started with a different number, and that's why that's happening. Don't worry about it, all right? What do you have to do now? Well, I'm going to say do the exercises, all right? As I do the exercises, what I do is I put down the numerical work that you should get. And again, if you're using a computer. Wells did not have this at its disposal. They had to employ people to do computations like this. Now the computations are cheaply done by a computer. But I put all the work down there for you. I'm hoping that makes sense to you and that you're going to get through that, all right? And I know it's a lot of work. I find it to be a lot of work too. I want to claim, though, that eventually you're going to get to the end of it. A lot of problems, by the way. It can't hurt to learn how to use a machine, though, including more efficiently than what I'm using with the copy-paste. There's ways to program this, all right? But what I want to claim over here, oh, boy, there's a lot of problems. They really worked people to the bone back then. I did the problems, though. I did every single one. Every single problem, all right? What I want to claim over here, though, is that, if I'm looking at this over here, what I do is I actually use Sage to solve the problems, all right? So someone's going to say, why do we need to learn a numerical technique? I'll be honest with you, you really don't. But here's the deal. If you want to be in that group of people that can actually do mathematics at a higher level, you'll need to know all this, not all the stuff, but you'll need to know a lot of the stuff that comes before you. All right. Now, someone says, no, I was going to use the machine to do that. Realize someone had to code these machines to do these problems over here. Now, I don't know what the code base looks like. I haven't looked at it. But the bottom line, they knew algebra. They knew how to solve problems. And they did a really nice job of doing it. Now, I don't think they're using numerical techniques to do these problems over here. But you realize you could solve these problems. Let me just clear this out for you. What I mean by that, you could type in a polynomial like this over here. Let me just do this again. F of x equals x cubed minus x squared, let's see, plus 2x, and that's minus 1, right? So, you could say solve. We were doing this before, right? Let me put this down for you. F of x equals 0, and we want to solve it for x. Of course, when I do that, I get something that looks really crazy. No doubt about it. So someone should say, oh, yeah, it looks crazy to me, too. There's just too much down over there. I want to point out that it's a cubic problem. There will be solutions to this over here. So what I do is I assign this over here. Let me put this down. S equals, and I'm going to copy paste this over here. I'm just talking through the code base. So now S is actually that long solution now. Same thing. So when I type in S with this notation over here, what I'm saying is the first entry. Now, the Sage card's counting from 0. And then I'm going to do right-hand side. We've seen this before in the code base, by the way. And I'm just going to put enter down, and I get that crazy-looking number over there. Now, if you want to approximate it, just put n and approximate it. That's a complex number. Now, I got this over here. Now, you might want to say, I wonder what the second entry would look like. That would be 0, 1. That's second entry. I get this number here. Let's say I want to do the third entry. You get the idea. You get that number over there. You get the idea? 3 numbers. Now, certainly, what I want to do is I want to copy this number here. You know what I'm going to do instead of that? I'm going to take this, and I'm going to take this whole thing here, copy it. I'm going to do F of, and you're going to see something strange happen. It gives me back something that doesn't make much sense to me. All right? The reason being it's not doing the computation. All right? Let me do this again. I know that looks strange to you. I'm going to do, back up a little bit. I'm going to do F of that number. Decimal. What do I see? Something really close to 0. Let's say I want to even go further back. Let me point out what I mean by that. This one over here, remember? And let's say I want to do F of that number. Let's see what happens. This might look crazy too. What I get over there, an incredibly small number. Again, close to 0. This is e to the minus 15, which means 10 to the minus 15. And this is going to be e to the minus 14 in the I. All right? You get the idea. Let me just go back up a little bit. I'm going to change this number to 0. That's the first entry. I'm going to do F. I'll do a copy paste over here. You know what I'm going to do? I'll do this over here. I won't even copy paste that thing over there. And watch what happens. All right? Really small number. What are we saying? They're the roots of the problem. All right? Be aware of that. It's easy to do. You want to learn how to use a computer to do a lot of your problems. Thank you for paying attention.